Right.
So how satisfied are you personally? This is a very completely opinionated question. How satisfied are you with accepting this view of reality that some things are just impossible to know? Like, are you like because for like the main reason I bring this up is because I was watching a video on Richard Feynman where he was I forget what it's called, but it's one of like the Richard Feynman interviews, and he was basically kind of expressing how he enjoys the fact that there are some things that we simply cannot know, and he's okay with it. And there's nothing
Are you
that
sure he said that? Or just some things that we
yeah,
don't
I
know?
promise on an interview he was like I like okay, I can't quote him, but I can definitely link the video in the description below, but I can't bring it up right now because I forget
Yeah, no,
which
but
one
that's
it
that's
was.
fine. Please do
But I
send me
think
the link
basically,
later.
yeah. So my question is
I'd be
basically,
surprised
are you
from him to
satisfied?
say that.
Mm-hmm.
Certainly, I'm not only am I satisfied with there being things we don't know, but that's what makes science fun. That's what makes
Mm-hmm.
science interesting. It is the
True.
quest for new things. And again, something you don't necessarily appreciate while you're taking courses, although by this stage, hopefully you do, and you certainly should, is that science is not about learning lists of facts and learning the rules that we already understand. It's learning how to progress beyond them, how to ask new questions and answer those. Um, and I think it's a fascinating, again, philosophical question of whether there are things we could never know or could never understand. There are people out there who say there is an ultimate theory, but it's probably just beyond us.
Mm-hmm.
And I'm not sure what I think about that. Whether whether I think that the human ability to abstract things is so powerful that in principle nothing is beyond that ability, or whether that's hubristic and there really are clearly things that would always be outside of human capability. Obviously there are things that are just too much for any individual human to understand. But the great thing about that is by now there's almost no one who understands all of the workings of the laptop that I'm on right now. But it doesn't matter. People get the big picture. They chunk,
Mm-hmm.
and there are emergent
Exactly.
phenomena. Um, as for this quantum idea, that maybe that's just how the world is, it no longer bothers me at all. Again, I don't like jumping to conclusions. I wouldn't want someone to tell me we know that you can't have all the information because I don't think they've proved that. If they proved it to me, then I'd say, okay, that's fine. I'm no longer so disturbed by it. My tendency, and this might just be common to experimentalists who have this need for a real visualizable picture of what's out there,
Mm-hmm.
is rather to say that you could, in principle, have a complete description of the world. You could, in principle, imagine writing down the wave function for the universe. And when people say that's incomplete, it's because they have the wrong idea of what a description should look like. Right? They're trying to ask where is every electron in the universe, and to me that then just becomes a misuse of language. That we're used to this classical way of seeing the world, but that's not really what the universe is like. It would be like asking, is the universe a nice guy? It's just a stupid question. The universe isn't a guy. It's not described by the emotional adjectives that I apply to human beings. And similarly, when I ask where are all the electrons in the world, I'm using the language that I use to describe, pebbles in front of me on the beach. And it's just the wrong concept, the wrong language. Um, I think when I was a student, that was kind of a modern way of thinking, to really picture the wave function as a real thing that could be out there. And as I've gotten older, I think it's become less modern. And by now, I think the people who really pioneered a lot of these quantum information ideas and those who moved on to work in foundations that I have the most respect for, I think they see my viewpoint as old fashioned. And they would say, no, actually, Bohr was closer to the truth, and the wave function is really only about information. It's only a description of what we can say about the universe, and it's not something that's really out there. But this is one of the debates that's so interesting, and it goes on now, and people write papers about what the consequences would be of interpreting the wave function as a real thing in the world, or interpreting it as just a description of information.
Mm-hmm.
More and more right now, it's trendy to try to understand quantum mechanics through this lens of information. Say maybe I should back up. Um, as I've told you guys, but not necessarily your audience, one
Exactly.
of the things that distinguishes quantum mechanics from a lot of other theories in physics, like the theory of relativity, is that it's not like Euclid's elements. It doesn't begin from some postulates and then derive things from that. Special relativity, you say, let's make these two assumptions and see where they lead us, and they lead to the entire theory. And quantum mechanics was just built up as this house of cards to support, what we saw experimentally. And in retrospect, you can go back and say, okay, I could build it from these 3 or 4 foundations and call them axioms. But the axioms weren't designed because of any philosophical ideas or even any experiment that showed us, that axiom has to be the case. And a lot of people feel like we'd understand the world better if we had the right set of axioms. If we said, oh, the reason quantum mechanics is true is because the universe wants to be like A, B, and C.
Hmm.
And we
Yeah.
don't know what the right, elegant set of axioms is. So many people now have this intuition, and it's nothing more than an intuition, that information theory, the power of quantum mechanics for treating information, might be a better way to do that. There have been a lot of interesting speculations about how you could write information theoretic axioms that would get you a lot of the underpinnings of quantum mechanics. But it's still a work in progress, and as I say, it might not lead anywhere. It's just how people like looking at the theory.